Swayam Prabha. Digital India. Educated India.
Okay. So, as per that we have discussed about the normal incident and double layer things. Now, okay, now we will go for the oblique incident. If the pressure wave incident on a two boundary, on just interface of the two boundary, instead of normally there is a oblique. So, this is the medium 1 and this is the medium 2 and characteristics will be R1 and R2. Velocity of the sound in here is C1 and velocity of the sound in here is C2. Now, if the wave is incident not normally, a oblique incident. So, a wave is create a angle theta I, which is the angle of incident of pi, incident wave, and the reflected wave will create the same angle theta r, which is theta I is equal to theta r, and this is PR, reflected wave, and there will be a transmitted wave which is PT, which is theta t, angle of transmission. Okay. So, what is Pi? Pi is the incident wave. So, it is the in the medium 1. Okay. So, pressure amplitude is Pi e to the power j omega t minus what is there? Angle with theta with the normal. So, the wave is propagated in xy plane with the angle of theta I. So, it is nothing but a minus k1. Wave number in the medium 1 is k1 x cos theta minus k1 y sin theta. Okay. Similarly, what is PR? Wave is reflected wave. Reflected wave again xy plane e to the power j omega t minus why it will minus or plus? It will be plus because it is positive x direction, negative x direction, but y direction is positive. So, this is x axis and this is y axis. So, I can write k1 x cos theta is positive minus k1 y sin theta. And what is PT? PT is nothing but let pressure amplitude PT e to the power j omega t minus the second medium. So, it is k2 x cos theta t. So, it is theta r theta I cos theta t minus k2 y sin theta t. Okay. So, this is the wave equation. Now, the condition at the boundary, what I said, at the boundary the pressure on both sides will be equal. So, at x equal to 0, pressure on both sides will be equal to same. So, at x equal to 0, the x term will be vanished at x equal to 0. So, I can write Pi e to the power j omega t minus k1 y sin theta I plus PR e to the power j omega t minus k1 y sin theta r is equal to PT e to the power j omega t minus k2 y sin theta t. Okay. So, e to the power j omega t, e to the power j omega t will be not there. So, I can write Pi e to the power minus j k1 y sin theta I plus PR e to the power j minus, it will be minus j k1 y sin theta r is equal to Pt e to the power j minus j k2 y sin theta t. Sin theta t. This is the condition number 1. Pressure on both sides will be equal. Then normal component of the velocity will be equal. So u cos theta I, let's it is u I cos theta I plus u r sin theta r will be equal to ut, sorry, ut cos theta r will be equal to cos theta t. Normal component of the particle velocity will be equal. Now from here, if I divide by that incident wave pressure, so it is 1 plus r is equal to t, 1 plus r is equal to t. Now here u cos theta I plus u r cos theta r is equal to ut cos theta t. Okay. Now you know that u is or p, relationship between the p and u is nothing but a plus minus r into u, and theta I is equal to theta r. These two things I know. Angle of incident is equal to angle of reflection, and p is equal to plus minus r by u. Okay. So sin theta I is equal to sin theta I or cos theta I is equal to cos theta r, sin theta I is equal to sin theta I. So for using this equation 1, this is equation 2, this is equation 1, I can get 1 minus r is equal to, I can write r1 cos theta t divided by r2 cos theta t into t. Okay. So from there I can calculate, I can find out the expression of r. You just simplify that things in yourselves. If you don't do, then I can discuss in discussion forum how to simplify this equation and derive. Then I will derive that equation, r is equal to r2 by r1 minus cos theta t by cos theta I, okay, divided by r2 by r1 plus cos theta t by cos theta I. This will be the r equation. Okay. So once I get the r equation, this is the reflection coefficient equation. I can calculate the t equation, 1 minus r is equal to or 1 plus r is equal to t. So I can calculate the t. Okay. So I can calculate 1 plus r is nothing but a transmission coefficient, pressure transmission coefficient. And another equation, the Sen's law said that sin theta I by c1, velocity in the first medium of the sound, is equal to sin theta t by c2. Okay. So from there I can say sin theta t is nothing but a c2 by c1 into sin theta I. Okay. This law, Sen's law. Okay. So if an angle of incident is given and speed of the sound is given in the two medium, then I can calculate sin theta t. Okay. I can calculate sin theta t, angle of transmission. Now come to the situation. Let us go to the some situation. Okay. So now if this is that if the sin theta t, I said sin theta t is nothing but a sin theta t, angle of transmission can be c2 by c1 into sin theta I. Now if c1 is greater than c2, then this ratio will be less than 1. c2 by c1 will be less than 1. So in that case the theta t will be always smaller than the theta I. So, angle of incident, angle of transmission always will be lower than the angle of incident. So, what do you mean by C1 is greater than C2? Velocity of the sound in medium 1 is higher than the medium 2. A practical example, if a sound transmitted from a water to air, if it is a sound transmission from water to air. So, in water sound velocity is C1 and air is C2. So, in C1 is greater than C2. So, if the sound transmitted from water to air, angle of transmission always will be less than the angle of incident. So, I can say if this is a water and this is a air, then I can say that transmitted ray should be bent towards the normal, or angle of incident. So, it is bent towards the normal. Okay. Now, other case, if C2 is greater than C1, if C2 is greater than C1, so this ratio will be always greater than 1. Okay. C2 is greater than C1. So, the angle of incident, and now I can say that theta t may be greater than theta I. So, theta t is greater than theta I, that means that angle of transmission, that transmitted wave will be away from the normal, transmitted wave will be go away from the normal. So, if it is go away from the normal, maximum can it goes to 90 degree. Okay. So, when if the angle of incident is such that the angle of transmission is 90 degree, angle of incident is such that the angle of transmission is 90 degree, then that incident angle is called critical angle. Okay. That incident angle is called critical angle. So, I can say if theta I want to say that theta I is a critical angle, then I can say C2 by C1 into sin theta c, the angle of incident for which the angle of transmission is 90 degree is equal to 1, or sin theta c is equal to C1 by C2, C1 by C2, where the wave is transmitted from a lower, the wave is velocity of the wave in C1 in medium 1, the which is incident wave in C1 and it is C2. So, that means if a wave, pressure wave come from air to water, if this is air and this is water, air to water. So, velocity of the sound in air is C1 and velocity C2 is greater than. So, C2 is greater than C1. So, in that case the angle of transmission will be away from the normal and the critical angle is defined by C1 by C2. So, theta c, the critical angle for which the transmitted angle is 90 degree is theta c, critical angle is C1 by C2. So, if I give you the velocity of the sound in two medium and I told you find out the critical angle, then you can say the critical angle theta c is nothing but a sine inverse C1 by C2. So, theta c is nothing but a sine inverse C1 by C2. Okay. Now, what will happen if the wave is incident in that condition where C2 is greater than C1 and angle of incident theta I is greater than theta c, greater than critical angle. If it is that condition, that means a wave, pressure wave is transmitted from a air to let us water and angle of incident is greater than the critical angle, then what will happen? Okay. So, I will derive the mathematical expression what will happen in that case, what will happen to the pressure wave, is it come back in the first medium as you know the light, total internal reflection, it is come back in the first medium, or what will happen? So, I have to find mathematically what will happen. So, we will start from that. If we say the sin square theta, or you say cos square theta I plus sin square theta t, or I can say cos square theta t plus sin square theta t is equal to cos square theta plus sin square theta is equal to 1. So, I can say the cos theta t is nothing but a root over of 1 minus sin square theta t. Okay. Now, what is sin theta t? Sin theta t is nothing but a C2 by C1 sin theta I. So, I can say it is nothing but a root over of 1 minus C2 by C1 sin square theta I, sin square theta I. Now, if C2 is greater than C1, if C2 is greater than C1, then cos theta t, sin theta t is a, and sin theta I is a real, and cos theta t is purely imaginary. If this product of this thing is greater than 1, then this cos theta t becomes imaginary. So, I can write cos theta t. So, angle of incident is greater than the critical angle such that this becomes greater than 1. Okay. So, if it is greater than 1, then cos theta t is nothing but a minus j root over of C2 by C1 sin square theta t, sin square theta I minus 1. I can write this way. Okay, minus j root over of C2 by C1 sin square theta t minus 1. Okay. Now, what is Pt? Pt is Pt amplitude e to the power j omega t minus k2x cos theta t plus minus k2y sin theta t. Okay. That is why I calculate the cos theta t. So, cos theta t is nothing but this one. Okay. So, I can write this is nothing but a Pt into e to the power minus j will be cancelled. So, if I say this is minus, let us gamma x into e to the power j omega t minus k2y sin theta t. Okay. So, j cos theta t, I put the value of cos theta t in this equation. So, gamma is nothing but a k2 root over of C2 by C1 sin square theta I minus 1. So, this term into k2 term I said gamma. So, e to the power minus gamma x e to the power j omega t minus k2y sin theta. Now, if you say, so transmitted wave is propagated along the which direction? Only y direction, because y is only there, x is not there. So, I can say the transmitted wave propagated along the y direction, and amplitude of the wave, if you see the amplitude of the wave will be decreased as per the x axis. As x increase, so wave is transmitted like this way. As x is increased, the amplitude of the pressure will be decreased. Amplitude of the pressure will be decreased. Now, if I say it is positive, if it is negative, then what will happen? If gamma is negative, then what will happen? The pressure will be increases. If gamma is negative, then it is e to the power p into e to the power plus gamma x, which means the pressure is exponentially increases as x increases, which is impossible. It cannot be possible in physical reality. So, only possibility is that if the angle of incident in case of oblique incident is greater than the critical angle, then the wave will be travel along the y axis and its amplitude will be decreases as x is increases. As we travel along the x axis, the pressure wave amplitude will be decreases. So, if x equal to 0, pressure wave amplitude is maximum, then at x equal to, if I increase, then it will be decreases, pressure wave amplitude will be decreases. Okay. So, as normal like to light, it is came back in the first medium, it is not came back in the first medium in case of pressure wave. So, I can say if it is a pressure wave propagate along the xy plane, now what will happen, that if instead of oblique incident in xy plane, the now if it is critical greater than the critical angle, pressure wave moves towards the through y axis and amplitude of that pressure wave will be decreases as we move along the x axis. Okay. So, this is the incident, that is the oblique incident case. For normal incident, that means the wave is propagated along the x direction only, y direction is 0 because normal incident. So, normal incident we have derived that things and we said the transmission coefficient is inversely proportional to the L, pressure transmission coefficient is inversely proportional to the L, and if intensity transmission coefficient is inversely proportional to the L square. In case of oblique incident, we said that yes, that critical angle we have calculate, we know the theta t, we can calculate, if we know the C1, C2, we can calculate the reflection coefficient and we can calculate the transmission coefficient, both we can do. Okay. So, oblique also you can do. Now, I am not going this thing that the power transmission coefficient, I am not going details because there is not that much of scope in this course to going all details. Okay. You can see that power transmission coefficient also. I will come, the simple problem is given. It is said that an earthquake P wave passes across a boundary in rock where its velocity increases from 6.5 km per second to 8 km per second. If it is strike the boundary at 30 degree, what is the angle of refraction or angle of transmission? So, what I said that a pressure wave incident on a, this is rock boundary. So, this is C2 and this is C1. So, from here it is incident with a 30 degree angle. So, what will be the theta t? I have to calculate the theta t. So, what I said, sin theta I divided by C1 is equal to sin theta t divided by C2. So, sin theta t is nothing but a C2 by C1 into sin theta I. So, C2 is given, C1 is given, theta I is given, I can calculate the theta t. Okay. Even if I told you calculate the amount, if the power is given, if the less the earthquake power is given, that pressure power is given. So, what amount of the power will be reflected back or intensity of the earthquake is given. I said the what amount of intensity wave will be transmitted in the rock. So, I know the T, if I know the T, from there I can calculate the Ti. Okay. Once I calculate the Ti, I know that how much amount of transmission multiply by the incident intensity multiplied by transmission coefficient, I get the transmitted power. Okay. So, that way you can know. Now, there is an important physical properties in acoustics wave transmission, which is mostly used in architectural acoustics. Generally, if you see in a factory, you see there is a lot of machine in a floor and there is a room which is separated by a glass partition. Once you inside the room, the sound which is created by the machine is reduced drastically. But you have studied that the transmission coefficient is partial transmission coefficient is inversely proportional to L. Then the length of the partition is very thin, glass partition, very thin glass partition. So, how the sound is blocked? This is contradictory. If you see, I said the length of the transmission coefficient depends on inversely proportional to length. But in a factory, if you see, there is a lot of machinery in the floor, and there is some enclosure which is made of a glass partition or some gypsum board partition, and inside that partition the sound intensity is drastically reduced, machine noise is drastically reduced. How it is do that? So, that is called mass law on a physical property. So, the portion, the partition is often material whose motion is normal to the interface regardless of the angle of incidence of the sound, and thickness is much smaller than the wavelength for the frequency range of interest. Okay. So, you know that the thickness of that partitions are very low, and the partitions are made of such material whose motion is normal to the interface regardless of the angle of the incident. Okay. Now, I go for the mathematics. What is there? If the intervening layer, that means it is nothing but so I can say, suppose I have a factory and I make a glass partition or gypsum board partition for office room. Okay. So, I have a factory, whole factory is in air. So, this is the partition wall, let us partition, this is a partition wall whose thickness is L, which is very low. Okay. Now, this side is air, in factory air, and this side is also air. So, if I say the intervening layer 2, this is the intervening layer. So, this is my enclosure room. So, this is the intervening layer. So, once the acoustic wave fall on this intervening layer, completely flexible with surface density, let surface density of this layer is rho into S. Surface density, surface area multiplied by the density is the surface density, treated as an interface possessing mass, so that the difference in pressure across the interface, equal to the product of surface density and its acceleration. That means, once the wave intensity or fall in pressure intensity fall in here, then particles are moved. So, difference of pressure, so this is Pt, this is Pr and Pi, Pr will be this direction, Pi will be this direction, and this is Pt. So, I say Pi plus Pr minus Pt, difference of pressure is nothing but a surface density multiplied by the acceleration. So, what is surface density? Rho into S is the surface density. Okay. What is acceleration? So, normal component of the particle velocity in here, this side is ui cos theta plus ur sin theta is cos theta is equal to ut cos theta. Let us, theta is the any angle of incident, theta is the angle of incident. So, if it is that, then what is the normal? I said that acceleration, surface density. So, the velocity is nothing but a ui cos theta is the velocity, or sorry, transmitted wave is ut cos theta is the velocity, surface density this side. Okay. So, if particle velocity of this portion, this thin layer, inside this thin layer is Pt. Okay. So, in that case, the surface density, velocity, particle velocity is ut cos theta. So, acceleration is nothing but a derivative of the velocity. So, derivative is written as j omega, d by dt is nothing but a j omega into ut cos theta. So, j omega is nothing but a d by dt. We said that in first lecture also, the d by dt we always treated as a j omega. Okay. So, j omega ps j omega ut cos theta. Okay. Then I can say 1 plus r is equal to T, transmitted coefficient, plus j omega ps divided by r1 T cos theta. Why I r1? because UP is equal to plus minus U into R. So, Pi divided by Pi. So, Pi is can be converted, okay. Pi can be, UTK can be converted by R, or Pi can be converted UI. So, it is nothing but a R1 T cos theta, okay. Now, from here, if I convert into the P, U is converted into the P by R1, okay. So, I can say UI cos theta is nothing but a Pi cos theta by R1 plus, it will be reflected wave, so it will be negative. So, it is Pi, this is Pi cos theta, PR cos theta divided by R1 is equal to PT cos theta divided by R2. Okay. Or I can say that normal component of this thing. So, U, or generally it is UI plus UT is UR is equal to UT. So, I can say 1 minus R is equal to T from this equation, putting P is equal to plus minus UR. Okay. Now, okay, forget about this equation. So, 1 plus RT is equal to this thing. So, from there 1 minus R is equal to T. So, using this equation, this is 1 and this is 2, I can calculate T, and then I can calculate Ti, which is nothing but a T square, which is nothing but a 1 by, if you calculate it, plus omega rho is S divided by 2 R1 will be cos theta whole square. Ti will be T square, which is 1 by 1 plus omega Ps divided by 2 R1 cos theta square whole square. So, this is the transmission coefficient in the second room. This is the transmission coefficient. So, if it is I, then will be I multiplied by Ti. So, Ti is 1 by 1 plus omega Ps 2 R1 cos theta. Now, if you think in the previous case, when we said that interval layer length is L, this is R1, this is R2, this is R2, this is R3. So, here R1 is equal to R3. So, for the normal incident case in the fluid, so that in that case the Ti is nothing but a 1 by 1 plus 1 by 4 R2 by R1 whole square sin square K2L. That is the normal case. Now, it is Ti, in this case Ti is 1 by this one. Okay. Now, if this is my transmission coefficient, then what are the relations, what is the transmission coefficient in a practical cases? So, I have a office, most practical situation in air of, so in a factory, if you see the factory, both inside the enclosure room and factory room, both are air, and the enclosure room is separated by a thin partition of gypsum board, or let's partition is gypsum board, let's plywood or gypsum board, and surface density is 10 kg per meter square, 10 kg per meter square. So, at frequency, let's f is above 60 hertz. If I calculate omega rho s divided by R1, which will be greater than 9, then I can say Ti, or if I ignore this one, this term is very large, then it is nothing but a 2 R1 by omega rho s cos theta whole square. Okay. Now, if I increase the surface density by double, if I increase the, so instead of 20 kg per meter square, if I use a material whose surface density is 10 kg, it is 20 kg per meter square. That means rho into S is increases 2 rho into S. Then transmission coefficient will be reduced by 1/4. So, every time if I double the surface density, the transmission coefficient will be reduced by 1/4. So, instead of plywood, if I use the glass, let surface density is double, then it will be reduced by 1/4. That is why if you see in a factory layout, the working place in a factory is separated by a very thin partition, which is create the mass law effect. So, that factory noise cannot go inside the room. Okay. So, there is a mass law is created. Sometime if you see that in acoustics isolation, when we make a door, instead of solid door, we make a glass door with the two glass, in between there will be air. So, it will be reduced. So, first this is the studio, this is a glass door in one layer. So, there will be inverse mass law calculating. So, if it is glass, then there will be air, again I have a glass, then the outside noise cannot go inside, because it is there will be a mass law affecting, and there will be also a mass law affecting in the two wall. So, the inside that auditorium, if the two separated glass door are used, very low noise will be outside, noise will be enter. So, that is why in acoustics, architectural acoustics, this is mostly used. Okay. So, next class we will discuss about the sound absorption and then sound field, means reverberation field. So, now we will go for the details to the practical application, what is sound field, then how to design that studio, that part will be going on the next week. So, from the next week, this theory is over now. Next week we go for the how design of auditorium. So, those things will be consulted when we discuss about those things. Okay. So, this theory will be, I will use this theory when we discuss about that, why there will be a door of like this, why there will be a wall of like this, why there will be a absorption coefficient is equal like this, how this is achieved, that kind of things. Okay. Okay. So, thank you.